Chapter 1. The Celestial Sphere. Cartesian and polar coordinates in space. Positional astronomy is the branch of astronomy concerned in determining the position of every kind of celestial objects. It is the most ancient and most important branch of astronomy. That is the reason why we start from this topic to study astronomy. We must first establish the fundamental elements of a reference system in space. Only after we have done that, we can establish a coordinate system to determine the object's position in space. Fundamental elements of a Cartesian orthogonal reference system in space: an origin point cap O. 3 oriented directions or axes x, y, z coming out from cap O, each one perpendicular to the others. The 3 oriented directions respect the right-hand rule. The position of a point cap P is defined by 3 Cartesian coordinates x, y, z. Orthogonal projections of the ray vector are equals open paren cap O cap P close paren over each fundamental axis. A direction angle is the angle between each fundamental axis and the direction of ray vector r. To fix a point cap P using Cartesian coordinates, the distance r must be known for each direction angle. X equals r, cosine alpha. Y equals r cosine beta. Z equals r cosine gamma. The distance r is positive or null. Each ordered triad of Cartesian coordinates corresponds univocally to a single point into the space and vice versa. Given 3 Cartesian coordinates of a point cap P open paren x, y, z close paren, the distance between point cap P and origin cap O and the direction angle amplitudes r equals square root of x squared plus y squared plus z squared and square root. Alpha equals inverse cosine of x over r. Beta equals inverse cosine of y over r. Gamma equals inverse cosine of z over r. Each direction angle varies from null to flat angle. The origin point cap O open paren 0, 0, 0 close paren is the only one in space for which all the coordinates are 0. The orthogonal Cartesian coordinates cap P open paren x, y, z close paren can be positive, null, or negative. Fixing the value of one coordinate alone is like fixing the plane perpendicular to the same coordinate axis on which point P is located. Fixing the value of 2 Cartesian coordinates is like fixing the straight line parallel to the third coordinate axis on which point P is located. Fixing the value of one direction angle is like fixing the infinite cone with vertex at origin point cap O and oriented as the corresponding Cartesian axis on which point cap P is located. Fixing the value of distance r alone is like fixing the sphere centered at origin cap O on which point cap P is located. Fixing the value of the distance r and one of the direction angles is like fixing a circle centered on and orthogonal to the corresponding fundamental axis on which point P is located. While you need only 3 Cartesian coordinates to define the position of a point in space, it is not enough having only the amplitude of 3 direction angles. You also need a fourth number, the distance from the origin. The reason is that the three direction angles are not independent parameters. If you are almost free to fix the amplitude of two direction angles, you can fix the amplitude of the third one choosing it between two possible values only. You need a fourth independent parameter to completely define the position of a point in a three-dimensional space, its distance from the origin.